Yes, hello everybody, and thank you for joining. My name is Daniel van der Zand. I'm sales manager here at Kowa, responsible for machine vision lenses. So about our content today, first I will briefly introduce the company Kowa. Then I will talk overall about transmission options we have for standard lenses. And then I will introduce our SWIR and VIS-SWIR lenses and talk about possible application cases. And when talking about VIS-SWIR, I will also briefly touch on the topic of focus shift. So what kind of company is Kowa? Kowa is a Japanese company. It was already founded at the end of the 19th century. And since then, from now, the company has branched out into many different business areas. And today, it is an internationally global company with more than 6,000 employees active in different fields of manufacturing and trading. And one important part of manufacturing is the design and manufacturing of optical products. Kowa already started to manufacture optical products in the 1940s. On this slide, you can see a glimpse of one of our factories in Japan. And optical products, one part of the optical products are lenses. We concentrate solely on industrial lenses. So industrial lenses means on one hand, machine vision lenses, which are mostly fixed focal length lenses, and then also security CCTV lenses, which are mostly long-range motorized zoom. So what makes Kowa lenses different? For our industrial lenses, we have a very broad product range. Broad means regarding the variety of image sizes we have, the variety of different resolutions we have, the variety of unusual focal lengths we have. Kowa positions itself in the higher optical quality segment, and we differentiate ourselves by technical features. So every time you would come to our booth at the Vision Show, for example, you see we have new innovative technical developments. Additionally, Kowa is flexible on customized solution, which we offer from a relatively low minimum order quantity. Now about the topic of transmission. So what is transmission actually? What does it actually mean? Transmission means what wavelengths of light can actually pass through the optical system of the lens. And this is mainly determined by the coating used for the lenses. So on this sheet, I have different transmission options we have for our standard lenses. So if you look at the blue line, this is a so-called single layer coating, which most of our standard lenses have. So this transmission has a peak at visible around 550 nanometer, and then slowly, continuously decreases up to NIR. Nevertheless, these lenses still have a solid transmission in NIR. And then please look at the red line. So this is a so-called broadband coating. Most of our higher resolution, higher quality lenses have. And this so-called broadband coating makes possible a continuously high resolution from visible 550 nanometer up to 900, 950 in NIR. So this is important for customers who need a really high transmission in infrared. And then the two other options about SWIR, which I will go into more detail about later. So if you look at the green line, you see the SWIR coating. So these are lenses specifically coated just for the shortwave infrared spectrum. So this is for customers who just want to work in the shortwave infrared spectrum. And if you look at the black line, this is our latest innovation. These are lenses with a coating all the way from visible up to 2000 nanometer up to shortwave infrared. So with these lenses, you have a transmission of the optical system from visible to shortwave infrared. So what are these lenses specifically we have in our portfolio, and what are the some use case examples? So we have a 1-inch lens series optimized for shortwave infrared. So this is for applications where you just need the spectrum from roughly 850 to 1900 nanometer. Here we have also a very wide range of focal lengths starting from 8 to 50 millimeter. Typical applications are like scientific applications, sorting, recycling. In the laboratory, we made some demo setups and tests to illustrate what actually can be done in this SWIR spectrum. So here, if you look at the image on the upper left, you see at visible coffee beans and flour. These are just two examples for substances. So invisible, the upper left side is the visible image. If you put a drop of water on these substances, it cannot really be differentiated or cannot really be seen easily. But if you look on the lower right, you see this same image taken in shortwave infrared. And on the flower, you see this black drop. This is the water. So water detection or moisture detection is one of the classical use cases for shortwave infrared food sorting applications. And we have actually taken much longer demo videos about it. So if you are interested in the different videos of all the use cases I present here, you can go to our YouTube channel, Kowa Machine Vision and CCTV lenses, and there you can see the demos much more in length. A different case of different SWIR application. So here on the upper left side, you see rice, which has some plastic in it, some white plastic. And in the visible image, this would be hard to detect actually. But if you look on the lower side, the SWIR image, you see the rice appears black, and in this case, the plastic appears white. So this is one other application in food sorting. And in fact, we also do have zoom lenses, also just optimized for shortwave infrared transmission. Different image sizes, 2 1-inch and 1 to 1.8 inch, so long range zooms. And these are popular for scientific applications. And of course, also other use cases are more in the security sector. Here I have brought one example. In this slide, you can see on the right side, the visible image. In these two images on the right side, you see the visible image, you see the colored smoke. In visible, just the colored smoke can be seen. But if you go to shortwave infrared, the camera and lens can look through the smoke, and firefighters could detect if there are still people to be rescued. And this chart you already have seen in the overview chart of the different transmission. Our latest innovation is a lens which goes all the way, has the transmission all the way from visible to shortwave infrared. And here you see this lens series. It is as well a 1-inch lens series. And the background why we have developed this is that more and more cameras actually have this transmission possibilities for the sensors. One of the example are the Sony sensors IMX990 and 991, which came out 2 years ago. And regarding this lens series, I also would like to point out the high resolution compared to other SWIR and our own shortwave infrared optimized lens series. This resolution has quite a high resolution and can resolve down to pixel size 3.1 micrometer, because, for example, these Sony sensors I just mentioned also have relatively small pixels. And now I would like to briefly touch on the topic of focus shift. This is also a topic a lot of people confuse. So what I talked about so far is the transmission. So what wavelengths of light can go through the optical system. So if a lens is usually you would say IR corrected, or in this case for this lenses you would say SWIR corrected, that means that if you switch the illumination from one wavelength to the other, that there is no focus shift. If this correction is not incorporated in the optical design, so actually for most standard lenses, then there is a focus shift. So if you have a standard lens and you switch the illumination from visible to infrared, you have to readjust the focus because it's a different wavelength. A common use case where this IR correction is needed are traffic applications which need IR corrected lenses sometimes, because in some cases during the day in traffic applications they use visible light during the day, and at night they switch to IR correction, and in that case they cannot readjust the focus. But this lens series here we see on this slide is not only IR corrected up to IR, here the focus shift is reduced up to shortwave infrared. So all the way, all the transmission through this effect, which occurs with most lenses, is reduced due to its special optical design. To make it a little bit clearer, on the left side you see here we have taken with this lens an image in visible, and we have switched the illumination to shortwave infrared. Of course, we have not adjusted the focus here, and then you see the image is still in focus. Here are other examples, or here to make it even more clearer, you have to look from the right to the left, and on the upper row, you see this SWIR corrected lens. So we have focused at 1650 nanometer, and then we went through different wavelengths without readjusting the focus, and you see the image is clearly in focus for all the different wavelengths. On the lower row, we have taken the other shortwave infrared optimized, not SWIR corrected lens series as a comparison. And here you see where the image slightly blurs when you change the illuminations, when you change the wavelengths of illumination. And what is this really good for? Well, this characteristic is most advantageous when you have one camera with which you work in shortwave infrared and visible. Then, of course, this camera has to have the transmission from visible to shortwave infrared. And if you have one camera system, and with this same camera system, you want to do inspections in visible and short-wave infrared, and you don't want to readjust the focus all the time, then these lenses play out their advantage. So this helps you to shorten the production time and the adjustment process, and possibly you could reduce your hardware costs. For example, if you see here on the lower upper left side, this classical example of the Apple in short-wave infrared. So if you use one camera system, and on the left side, you inspect with this camera system the exterior of the Apple in visible, and then you check for pressure points, which can be only seen in a short-wave infrared. Then the water part appears black, and then you could use this lens. Or the other example on the upper right side, if you use one camera system and you inspect a package from the outside invisible, and then you switch to SWIR and you want to inspect what is actually inside. This was the application example for VIS-SWIR. And this was my presentation about the different transmission options. The Kowa lenses we have for SWIR and VIS-SWIR, and some application examples. I would also then like to point to our website, kowa-lenses.com. There we have all the data sheet of all the lenses on our website. We have 3D data. We have a newly updated lens calculator, which you can use to calculate the lens you need specifically for your parameters. And I have already mentioned our YouTube channel, Kowa, Vision, and CCTV lenses. There you can look at lengths at these demo examples I talked about, and many other interesting videos. Here are my contact details. Feel free to contact me. We always offer to customers who are interested in testing these lenses, we offer that we loan you lenses for testing. If you are interested, please contact me. And of course, visit us at the Vision in Stuttgart 2 weeks from now. We are at booth 10B40. And then, yes, thank you very much. And I'm looking forward to your questions.
We already have some, Daniel. Okay, will the distortion be affected by this special coating?
Well, this really depends on the coating in that case. But distortion is a different aspect actually than the coating. Yeah,
it's just a suggestion also to the other presenters. Yeah. Maybe you can write your email address at the chat so everyone is able to get in direct contact if you have special questions for everyone. But we go on with the next. Boris, how fast can you write? Yeah. Then there's the next question. Can you supply telecentric lenses with a VIS-SWIR broadband coating and full range focal correction?
Telecentric lenses, not. Now these are only endocentric lenses.
Mm-hmm. Any more questions? Yes. Can you work with a single layer coating in IR, in infrared?
Yes, as I showed the transmission sheet, this single layer coating has still quite a solid transmission in IR. So I know of a lot of customers who use filters to work in 850 nanometer, for example, and use these single layer coating lenses.
Another question, more and more UV, ultraviolet cameras are coming to the market. Do we have the same effects for this optics? Do we need also special lenses, special coatings for UV cameras?
Yes, of course, the lenses need to be designed for this wavelength. And well, we are actually developing now one UV lens, which is planned to be released next year.
And does Kowa also have a more wide-angle SWIR lens?
Yes, for the lens series optimized for shortwave infrared, we are also developing a 6 mm more wide-angle lens, which will be also released next year.